In this session, we are going to discuss a new data structure in stacks. So, a stack is a data structure that follows lost in, first out architecture. As you can see here in this particular diagram, so a stack would have its most recent entry being inserted at the top of that particular stack there, and then every time we are trying to pop something out of the stack, we are removing the top element as well, right? So every time we are adding something to a stack, it's known as a push operation, and every time we are removing something from the stack, it's known as the pop operation. So as you can see, so the add or the push operation is being done to the top of the stack, and the pop operation is also done at the top of the stack. There is one another operation called peek. So peek operation would often just return the top element. It will not remove the element. Pop will remove the element, but peek will simply return the top element in that stack. So when it comes to stack, we could implement it in a variety of ways. We could implement a stack using an array list. We could implement a stack using a linked list. And then you have a built-in stack class in Java framework. So Java supports a built-in framework in stack. And we could implement the stack using vectors. So vectors is simply another variation of an array list, right? So again, it's a dynamic structure which will grow the array. It's not fixed in size. It's dynamic. So it's similar to an array list, right? So one could use a vector, or one could use a dynamic array, or one could use a fixed size arrays. So when we say dynamic array, we had learned in our earlier lessons how to create such dynamic array. So one would go back and look at the shopping cart example that we did, where we had grown the array, where we pretty much added 5 to the size of that array, and we had grown it. So a dynamic array is something that initially takes up a fixed size, and we are going to grow that array every time the capacity would reach. So there are a variety of implementations that one could do when it comes to a stack. And as you would find out from our implementation, that implementing a stack is should be pretty simple process, as we had done a variety of implementation using linked list. So the only thing that we will do here in our implementation, when we implement that is using a linked list, is that every time you have a linked list, let's say you have a linked list like this, you're adding to the front of the list. Every time you're adding to the front of the list, and you're also removing stuff from the front of the list as well. Right? So push is added to the front of the list, and then pop is again added to the front of the list. And you could invert this structure here, although it is horizontal, horizontally laid out. If we can lay it out vertically, let's say, then simply the front that we are referring to is the top, right? So the front that we are referring to becomes a top if we would lay it out vertically instead of horizontal. Okay, so at this point we should be fully equipped to discuss some code here and implement a stack, and then we will also do some experimental study to compare let's say an array list implementation with a linked list implementation, and then with the default built-in stack class implementation, and we will also look at a vector implementation today as well, right? So we will look at a variety of implementation of how one could deal with this stack data structure. So now we will shift our focus to discuss the code. Links.java file, we had set up the basic methods that are needed for the stack implementation using the linked list. So you could see that we have a method called push, we have a method called pop, and we have a method called peek and display and size. So this is not much different from what we had implemented earlier, if you would recall, with the linked list. It is very much similar to the linked list implementation. So you could see that we have a node.java where we have initialized the data and next variables, and we have our getter and setter. And then the links.java is having a method in push, which is similar to the add method, if you would recall, except that here we are adding something to the front of the list, right? So and then we are, instead of having a head pointer, we are having a pointer that is called top. And you could see that if top is null, then we simply set top equal to temp, else we are setting temp.setNext is top, and top will now become temp, right? So it is like us saying that add something to the front of the list, right? And then we are incrementing size to make sure we are capturing the total size of that list. And pop here is no different than a remove, except that here we are trying to remove something from the front of the list as well, right? So that's why we don't need to do a while loop. We don't need to iterate through the loop because we are simply removing something from the front of the list. So we have node temp equal to top initially, and then we are doing top equal to temp dot get next, meaning we are changing the top to a new top now, and then temp dot set next would be set to null. We decrement size, and also keep in mind the pop operation returns that integer, and at the same time it will remove the element from the stack as well, right? So this is why it will return that res, which is the result. And peek here is very much similar to the pop, except that it is not going to remove the element. Instead it will simply return whatever the element is in the top of that array, right? And display should be very familiar to all of us here, because we had done something previously where we had displayed the elements in the linked list. So this is going to be exactly the same, right? So you have node current equal to top, and then you have your while loop, and you are going to print the individual elements that way. So I like to go to our stack driver.java, and let's get familiarized on how to operate on this new implementation that we had done using linked list for the stack. So initially we are creating an object like what we often do for the links, and then we are doing a list of push like 10, 20, 30 all the way to 50, and then we call the display method, and then we are doing a pop. Keep in mind, pop will not only return the top element, but it will also remove that element from the stack, right? And then you have link.display, and then later you have your peek, which will only return and it will not remove it, okay? And then you have your link.display. So let's go ahead and compile and run this program. So I'm going to run this program here, so you could see when I run this program, I get my list 50, 40, 30, 20, 10. Keep in mind, every time a new element is added, it's added to the top of that stack. In other words, it is added to the front of the list. Then we are popping 50. So 50 would be removed from the list. As you can see now, you have 40, 30, 20, and so on. and then peaked 40. So peak will not remove the element, instead it will only return the element that is of interest to us, right? Okay, so let us also look at one other implementation of this stack here. And this implementation is going to be in blinks .java. So we have a built-in class in stack, and then using this built-in class in stack, one could actually build the stack, right? So you could see that we have our push operation, which is the method that we had created, and then we are using stack.push to push the data, and then pop, where we are using stack.pop, and then stack.peak, and finally stack.size, right? So it is a built-in inside Java framework, and we need to do an import the library java.util.stack, and then we should be able to use this stack built-in structure, right? And let us also look at the implementation in clinks.java, where we are implementing it using an array list, right? So an array list, as you would remember from our previous discussions, is simply an extension of what we have with an array, except that it is a dynamic and customized array, right? So you could find that we are initializing that stack, which is an array list. We are doing that in our constructor, and then we are creating a push method where we are using the add. Simply we are adding something to the array list, and pop would be removing the lost element that was added. So the way we would do that is we would simply do stack.size -1, so we can then remove that from the stack. And then we have our peak, right? So again, peak would be stack.size -1, which is the most recent entry inside that particular stack, right? And size would simply be stack.size, which will give us the size of that array list. So let us also look at dlinks. A dlinks is using a vector, and keep in mind the stack built-in class is using a vector inside it, right? So you can see that then we have our stack equal to new vector, and then stack.add, we are adding something, a data element in the push, and we have the remove method in vector as well, and then peak and size is exactly the same way that we did with an array list. And let's keep in mind that we need to import java.util.vector in order to use a vector, right? And again, the key difference between an array list and a vector is that a vector would, when it is growing, it grows slightly different than an array list. So if you recall, array list was 1.5 times growing ratio, whereas a vector here would pretty much double in size, right? Okay. All right. So at this point, I'm going to end this video, and we will do some experiments today to understand the implementation for all these different categories, right? Okay. Thank you.